This exercise had you developing terrain data analysis for your municipality. You were asked to create a painted relief map, a slope map, and an aspect map. I'm going to use East Hanover Township as the example for this solution. So you were asked to add the mosaic DEM for Lebanon County to the map, as I have shown here, as well as your municipality boundaries. You were also told to make sure that you turn on your extensions so that you have the correct tools available to you. So the way I'm going to start is by selecting East Hanover Township, and then I'm going to go to my image analysis window, and I'm going to clip the DEM based on the boundary of East Hanover Township. So I would select the DEM up here at the top and go down to this tool here that allows me to clip. So when I click on that and then turn off the main DEM, we see that we only have the DEM for that particular township. So now I'm going to turn off my townships, and I'm going to zoom in to my township. And one thing that you must know is that this data is not a permanent data set that exists on your computer. It's temporary within this project. So if we want this to be permanent, we right click on it and go to Data, Export Data, and we export it into the folder of our choice, calling it what we want. So I'm just going to call it EH for East Hanover, and then keep the rest, and then I'm just going to hit Save. And you can see at the bottom of the screen, it's in the process of exporting that to a permanent file so that we have it. So that would be the first step that you would want to take if you're just doing it for your entire township. If you decide instead with this exercise just to use the full county DEM, that's fine. You just won't have to go to this step because that data is already permanent on your computer. So you can just proceed with developing the painted relief map, the slope map, and the aspect map. And because this is a raster data set, it just takes a minute or two to process. Once it's done processing, it adds it to the map and your table of contents, so you can get rid of the temporary one and just work with this from here on out. So now that we have the DEM clipped to our area of interest, we can start creating the other data sets that have been asked for. We can create a painted relief. And if you remember, there are two different ways of creating a painted relief map. The first is to go to the image analysis window, making sure that your clip data is the one highlighted, and then simply select this shaded relief. And what you get is a really pretty shaded relief map. And again, this is not a permanent file, so if you would want to make this permanent, you would have to right click on it and go to Data, Export Data to export it as a permanent data set. And I'm not going to do that just because it just takes a lot of time to process it, and you'll be able to do that on your own. So once you do that, you can then go to our toolbox to generate contours for your shaded relief map. So we click the contour tool, and that will open for us. And once the tool is open, you input the DEM, the digital elevation model, not the shaded relief, and then you tell it what you're going to be naming the contour data set. And I'm going to try contours at a 20-foot interval. So I'm going to put that in my name. I'm going to put 20. And then hit OK. And again, you can see the contour tool running at the bottom. While that's processing, I'm going to get ready to show you the other way you can do the painted relief map. The first thing you would do is make sure that you symbolize your DEM with an elevation color scheme. And we go to our symbology tab, right click on that and go to elevation and select that. So while we don't see that because it's covered up by the shaded relief, that is now symbolized using that color scheme, and the contours are still running. And that's something to know, is while tools are running, you can still work in ARC. In previous versions, it was really difficult to do that. They've made some headway in allowing you to multitask, but as you just saw there, it can be a little slow for things to open when you do multitask. So the contours are now added to the map, so we can symbolize them in a better color than green. Or you might even decide, hey, you know, I don't really want them to be a 20-foot interval because they might be a little bit too tight. You might go for something a little larger, or even, for that matter, a little smaller, depending on what your application is. But that's how you create the contours. Now back to these other way of creating a painted relief map. We can do that by using a combination of the DEM with the hill shade, which means that we then have to generate the hill shade. So to do that, we just input the DEM. We save our data in an appropriate location, and then we just click OK. And again, the tool begins to run and process. So the hill shade is now on the screen, and to create the effect of painted relief, we bring the DEM on top of that, and then just change the transparency of the DEM so we can see both. I usually use something around 60 to 70, hit OK. And now we have a lovely painted relief map that, again, we can just overlay the contours on top of. And we probably want to label our contours. And something to make note of that messes people up a lot of times, when you go to label them, it's going to label by the incorrect field, which is problematic. It's if we look at these, we had a contour interval of 20, and when you look at these, none of these are a multiple of 20. And the reason why is because it's labeling the ID field rather than the contour field. So we just have to go into our layer properties and go to our labels tab and make sure that we select the contour field as the label field. And then we will get the right interval showing on the map. And you can see now that they are all multiples of 20. So that's the first map. And just something to make note of, we are creating these data sets for a very large geography for the whole entire township. So these tools are going to take some time to run. So if you're maybe freaking out because they're taking so long, don't. You just kind of have to sit back and relax. I hit the pause button on my recorder so you didn't necessarily see the length of time that it took, but some of these can take a little bit of time to process when we're using such a big area. So the next one that you were asked to create is the slope map. And again, we just go over here to Arc Toolbox, go to Slope, and we input the DEM, the one that we clipped, and then we just put our data in an appropriate file location. And something you have to remember once you're doing this is your units. Are you doing it in degrees and or percent rise? Because that should be in your legend so that the map user knows how to interpret your map. So I'm going to just select degrees and hit OK. So our slope tool has run, and you can see the result. To interpret this, the greener areas are the flatter areas, while the red areas are the steeper areas. Something that you're probably going to want to do in your legend when you make a map of this, you're going to probably want to clean up the number of significant digits, and you're probably going to want to put the units with your file name or your data name. So I'm going to type in slope in degrees so that my audience knows that. And then I'm also going to go to my symbology tab and click on the labels to go to format labels and change my number of significant digits to something that's not 10. I'm going to maybe do 4. And notice how that cleans that up, and then I can hit apply and just makes it a lot more readable. And I probably would even go to 3 significant digits instead, and I might edit some of these class breaks, but you can just see that it makes it a little bit easier to read. I'm going to turn that off because it really takes it a long time to draw, and we're going to do the last one, which is the aspect. Aspect is showing the direction of slope. So to run the aspect tool, we open it up, we input the DEM, and that's something I want you to really hone in on. Every single input raster for any of these tools has been the digital elevation model. That's the starting point for train analysis. It's not going to be any of these others, and sometimes you might get confused because there's all these data sets in here. Make sure you're grabbing the right one. And then again, I'm going to just put this in a folder and hit save and OK. And this will probably take, again, another 5 to 10 minutes to run. It's what the others seem to have taken. So if it's taking your computer that long, that's normal. You just kind of have to sit back and chill as that is working. So the aspect tool finished running, and it's still redrawing, which takes it sometimes a little bit of time, but you can see what you get when you get your aspect file. It's essentially telling you the direction of the slope. So this legend should be on your map when you create your final product, so you can kind of take a look at the map to see which slopes are facing which direction. So that was essentially what the exercise asked you to do. The key thing about this exercise, and the reason why this exercise we want you to do this exercise, is so that you create these train data sets while you have the 60-day free trial, because you have all the extensions and all the capabilities. So if you create them, you're going to have this data to work with from here on out. You don't ever have to do this again, but you have the luxury of having some really good data that can help you do some different types of train analysis.